In May 2025, an extraordinary discovery off the coast of Labrador, Canada, captivated the world's attention. Fisherman Halur Antoniusson, aboard the Sapudi trawler, spotted an iceberg unlike any he had ever seen before. Floating silently in the frigid waters, this iceberg was not the familiar white or blue, but a striking, deep black, its diamond shape looming 3 times larger than a typical bungalow. Antoniusson's photograph quickly circulated online, drawing the curiosity of scientists and the public alike and sparking a flurry of questions. How could an iceberg be black? Where did it come from? And what secrets might it hold within its ancient core? To understand the significance of this discovery, we must first consider what makes most icebergs white or blue. Icebergs typically form when chunks of glaciers break off and drift into the ocean. Their color results from the reflection and scattering of light within the ice, often influenced by trapped air bubbles and the purity of the ice itself. The blue hues occur when dense, pure ice absorbs red light and reflects blue, while white ice tends to contain more air bubbles that scatter all wavelengths equally. But the black iceberg Antoniusson encountered was a rare exception. According to glaciologists like Dr. Lev Tarasov from Memorial University, the iceberg's coloration points to a remarkable origin story. Over millennia, as glaciers grind and move across land, they pick up rocks, mineral dust, and sediments. This material becomes embedded in the ice, sometimes forming what scientists call dirty ice. In the case of the Labrador iceberg, the sediment concentration was so extreme that it absorbed nearly all visible light, giving the formation its black appearance. The iceberg's smooth surface and geometric precision suggest that it formed under immense pressure, compressing out air pockets and resulting in a dense, almost metallic sheen. Some researchers have proposed alternative explanations for the black coloration. Volcanic eruptions or meteorite impacts could have deposited ash or cosmic dust on the glacier's surface thousands of years ago. Over time, this debris would become trapped within the glacier's deep layers, eventually calving off as part of an iceberg. The age of such ice can range dramatically, from about 1,000 years to potentially 100,000 years, making these rare formations frozen time capsules that offer glimpses into the distant past of our planet. Each embedded particle within the black ice may tell a story about ancient environmental conditions, volcanic activity, or even the arrival of meteorites from space. But color is only one part of the story. Scientists were equally intrigued by the iceberg's texture and density. Unlike the typical iceberg, riddled with air bubbles and surface irregularities, this specimen displayed a remarkably smooth exterior. Such uniformity indicates that the ice originated from deep within a glacier, where compression over thousands of years squeezed out air and left behind a solid, glass-like structure. This unusual characteristic can affect how the iceberg interacts with sunlight, water temperatures, and even the surrounding ecosystem. As sunlight is absorbed rather than reflected, the iceberg may melt more quickly, releasing its ancient cargo of sediments into the ocean. The discovery has prompted new research into the dynamics of glacial movement and the factors that contribute to the formation of dirty ice. Scientists are eager to sample the iceberg's core, hoping to analyze its sediment content, determine its age, and unlock clues about climatic conditions from eras long past. The event also raises broader questions about climate change and glacial melting. As global temperatures rise, more ancient ice, potentially rich with geological and atmospheric information, may be released into our oceans. For residents and tourists in Newfoundland and Labrador, the black iceberg has become a local sensation, drawing visitors eager to witness the phenomenon firsthand. But for scientists, its appearance represents an invaluable opportunity to deepen our understanding of Earth's history, climate, and the ever-changing forces that shape our planet. In the end, Antoniusson's chance encounter reminds us that the natural world still holds surprises, mysterious, beautiful, and scientifically profound. The black iceberg's silent drift offers a powerful symbol of nature's resilience and the stories waiting to be uncovered within the frozen archives of our planet.